So in the final lesson of 3.2, we're going to be solving questions based on constant acceleration. There are going to be two parts in this video. We're going to split it into two things. We're going to split it into the part where we talk about the area under the graph, like for example, if we have a graph here and we want to talk about this area and what it means. And then we're going to talk about the equations of motion and all the formulas for them. So we'll start with the area under the graph. So here we have acceleration with constant motion, so constant acceleration. And what do they look like? What does a graph of constant acceleration look like? Well, one, you're going to have a normal linear graph, uh, a exponential graph. So this will be xt, this will be vt, this will be at. So if it's constant acceleration, this is obviously going to be a horizontal line. And if it's a vt graph, it'll be a linear line. So a linear line. And then an xt graph would be an exponential line. So when you talk about constant acceleration, these are the three types of graphs you're going to be dealing with. Now onto the area under them. So the area under an xt graph, let me change the color, means one thing, nothing. There is no physical meaning. uh, there's no physical meaning under this. This, no meaning. So the area under an xt graph has no meaning. How about the area under a vt graph? What does that mean? So the area under the vt graph the represents the change in the displacement. So delta x. So if we were to calculate the area of this triangle here, I want to calculate the triangle here, then we would get the displacement of the object traveling. And it makes sense because if you think about it, as time goes by, like if you were to take like 5 seconds here, and you're traveling at 2 meters per second, then if you were to actually multiply them, you would get uh, 5 seconds. So 2 meters per second times 5 seconds, and you were to multiply the units, it would be something that looks like this. So 2 meters per second times 5 seconds, and the seconds would cancel out, and you would be left with 10 meters. So it actually makes sense that it gives you the displacement. And you have to make sure it's not the distance under the graph, it's the displacement. So delta x and not just x. Now finally, the acceleration, the area under the graph here, represents the change in velocity. So delta v. And this also makes sense because if you were to also multiply the units, so if this was 5 and this is 2 again, so 2 meters per second acceleration, 2 meters per second squared, and this was 5 seconds here. At this point right here, if you were to multiply them, so 2 meters per second squared over 5 seconds, it would cancel out only one, and it would be 10 meters per second, or velocity. And again, it's not just velocity, it's the change in velocity. So it would be v final minus v initial. This is what it would give you. So we need to understand how to calculate the areas of every single type of graph, and that will give us two pieces of information. Now, the areas under the graph themselves all have their own formulas. So for the first formula we're going to cover is for the triangle. So let's go ahead and draw a triangle here. If you already know it already, it's pretty simple. It's uh, for a triangle, it's equal to half base, actually, half the base times height. So this is the formula for a triangle and the area of a triangle. Now the formula for the area of a square is equal to side squared. So if you want to find the area of a square, you just multiply one of the sides by, you square one of the sides. And for the rectangle, the area of a rectangle is just length times width is equal to length times width. And finally, we need to know the area of a trapezoid, which is uh, half the base. So base 1. So this would be base 1 right here. Base 1. And this is base 2. So base 1, base 2. It doesn't really matter which you take. You're going to add them anyway. So it would be base 1 plus base 2 over 2, and then you multiply it by the height. So the height would be this right here. Or if you were to take it from the outside, be this. So this is the height. You cannot take this as the height. This is not the height. This diagonal right here. It's not the height of the trapezoid. It has to be a line that is a vertical line that connects to both places. So like it'd be like this. And that is it for the areas. We're going to solve a few questions on them now. So to solve area questions, as we mentioned before, we need to find the displacement, or you have to find the area under the graph. So if it's a VT graph, we mentioned before that it is the area under it means delta x. So area under VT, or over in this case, under VT equals uh, delta x. So in this question, it asks us what is the total displacement. So we want the displacement from here all the way to the end of the object. So we have two different shapes here. We have a trapezoid and we have a triangle. Now we need to mention that we don't take the full area like this. We don't take it like that. We take the full area from the x-axis. So only till the x-axis. We need to keep that in mind. And to solve this question, the area of a trapezoid is equal to area, so we can call this delta x1, and we can call this one delta x2. So delta x1 is equal to, so base 1, so you can call this base 1 right here. Call this one base 2. So base 1 is, you have to count how much meters it is. So it's around, so this is 5 plus 10, so that's 10, so that's 15, then 5 again, so that's 20. 20, and then we add 1, 2, 3, 4, 5, 6, 7. So 7 times 10 because it's per unit 10. So we have 70 base 1. So 20 is base 1, this one, and this is 70, so we add two bases. It's going to be equal to 20 plus 70 over 2, and then you multiply it by the height, which is 3 meters. So we just take this line over here, which is 3 meters. So times 3. And then if we do the math on a calculator, we get 135. So just equal to 135 meters. So this is for delta x1. Now for delta x2, it's a triangle, so we're going to do half the base times height. So over 2. The base will be equal to, you can take this if you want. So 10, 20, 30. So 30. And then times the height, which is -2. So we have to take -2 because it's displacement, remember? So we do take the vectors and we take the negative sign, which is equal to -60 divided by 2, which is -30. So -30 meters. And then if you want, we have to find the total displacement. So it's asking for the total displacement. So we should add delta x1 plus delta x2, which is equal to 135 plus -30, which is equal to 115 meters. And that is the total displacement of the answer. So for this next question, we have an acceleration time graph, and as you know, the area under acceleration time graph gives you the delta v. So this is the rule. So yeah. So to solve this question, it asks an object starts with velocity of velocity of 3 meters per second, and he wants to know the velocity after 9 seconds. So he wants to know the change in velocity. So that's delta v, and to calculate delta v, we need to find the area under the graph. So we have two different triangles here. We have one over the graph and one under the graph. And whenever there's what's it called again? Whenever there's a line or a shape underneath, and we're calculating the area for it, on the negative side, then it'll be negative. So to find this one, let's name this one delta v1. We'll call this delta v2, and we calculate delta v1 now by using the formula. So delta v1 is equal to half the base times height. So half base here is 7 times the height, which is 3. So 3. So 21 over 3. So we calculated, and it's equal to 21 over 2, which is equal to 10.5. So 10.5 meters per second. So that's our delta V1. Now to calculate the next one, we'll do the same thing, half the base times height. So if this is the base and it's around like 1 here, so the height is going to be 1 times 1, 2. So 2, 1 times 2, which is equal to 1. So 1 meter per second. Now it's negative because it's on the negative side. So it's negative 1 times 2. It's going to be negative 1 meter per second squared. So that's our two velocities. And now we'll add them. So delta V total is going to be equal to this plus this. So it's going to be 10.5 plus negative 1 meters per second, which is going to be equal to 9.5 meters per second. This is going to be the total velocity, or the velocity after 9 seconds. So the question doesn't ask us for the total velocity or the change in velocity. It's asking for the velocity after 9 seconds. Now we calculated the change in velocity so that we can substitute it in the formula, and we can get this. So we will do 9.5, which is the total velocity, equal to 10.5, or we already know that delta V is equal to V final minus V initial. We have delta V, which is 9.5. We want to find V final, and then we know V initial is going to be equal to 9 or 3 meters per second. So we add 3 here, add 3, we add 3, and then the V final is going to be equal to 12.5 meters per second. So this is the velocity after 9 seconds. Now, for the equations of motion, we have five different formulas, one of which you already had taken and used before, or two of actually you've already used before. Now, when we want to use these equations of motion, we use them based on what is given to us. So let's start with the first one, which is, let me change the color, the first equation of motion, which uses delta x. So if we want to find the displacement, which is equal to half at squared plus vi multiplied by t. So for this equation of motion, we'll use it when v final is not given. As you can see, there's no v final in the equation. And it's important to note here that if the v initial starts from rest, or vi is equal to 0, then we can completely cross out this one part here. So it's pretty useful to know these little tricks. Now the second equation of motion uses v final, which is equal to a t multiplied or added to vi. So this one is one I used before. It is a linear y equal mx plus b. equation, and it's important to note if, of course, if it starts at rest, then this is just plus 0, so we don't need to have it. Now, we use this equation when delta x is not given, so when you don't have delta x, then we can use this one and to find anything or the givens we want to find. Now, next up we have v final squared plus v initial squared. This is a new one, and multiplied by 2a delta x. Now we use this equation when we don't have time, so this one is time independent. Independent. And this one, whenever we don't have the time, we can use it to find givens. Next up, we have equation which is delta x is equal to v initial plus v final over 2, and then multiplied by delta t. We use this one when the acceleration is not given, so as you can see, there's no a in the equation. So if you want to find givens without a given, then we can use this equation. And finally, we have the v average is equal to v initial plus v final over 2, or delta t. Now, we can use it over 2 as well when the time is equal to when delta t is not changing. But for now, we can keep it as delta t, and use it. We use this when delta x is not given, or a is not given, or when delta t is not given. So actually, delta t isn't given, you'd use 2. And if we want to find the average velocity from 2 points, and delta t is given in a graph, then we use delta t. So don't confuse these two formulas. This is when delta t is not given. So no delta t, we use this. So now knowing these equations of motion, we can solve most questions based on velocity time graphs, acceleration time graphs, or word problems. So we're going to do some exercises on these equations of motion. So for this question on equations of motion, we're going to solve this question here. So a car slows down from 22 meters per second. So this is v initial to 3 meters per second. So this is v final at a constant rate of 2.1 meters per second. So this is the acceleration. How many seconds are required? So we're looking for delta t before the car is traveling at a forward velocity of 3 meters per second. So, solve this question, let's just list out everything we have first. So we have v initial, which is equal to 22 meters per second. We have v final, which is equal to 3 meters per second. We have the acceleration, which is equal to 2.1, not 21, 2.1 meters per second squared. We don't have the time, so we're looking for the time, and then we can plot this all into one of the formulas here. So which formula will we use? So we want to find the time, and we don't have, and we have acceleration, so we can use this formula over here. If you find another formula that you can also use, that's fine as well. You can use whichever you want. So I'm going to use this one right here, and let's solve it. So v final, I'm going to write it again, is equal to at plus vi. So v final here is 3 meters per second. Oh, okay, but just to note here, the car slows down from 22 meters to 3 meters, so the acceleration should be negative. Negative 2.1 meters per second. You have to pay attention uh, to the signs of the equations, because you will get a wrong answer if you don't pay attention to if it's slowing down, speeding up, or which directions they are going to. So here it's 3 meters per second is equal to negative 2.1 multiplied by delta t, and then plus the v initial, which is 22 meters. So we can just plug this into a calculator and shift solve it. So x plus 22, and then we get 9.4 seconds. So v final equal, or delta t, not v final. Delta t is equal to 9.04 seconds. And that is the answer. So it's pretty simple. Equations of motion. Basically, you're just putting in the given and you're solving the question. So here we have a skateboarder and he's moving at a constant speed of 1.75 meters per second. So we have the skateboarder here and it's moving at a constant speed of 1.75 meters per second. And then she starts up an incline. So she moves up. That causes her to slow down with a constant acceleration of negative 0.20 meters per second. So moves at negative 0.20 meters per second squared. So how much time passes from when she begins to slow down? So we want to find the delta t. So when she begins to slow down until she begins to move back down the incline. So she's gonna go back down the incline. So let's write it all down. So like it starts moving at a constant acceleration or constant speed of 1.75 meters. And then at this point over here, it's starting moving up an incline and with an acceleration negative 0.220 meters per second. And then it stops, right? Because she begins to slow down until she begins to move back down the incline. This me this means right here that she went up, stopped for like around whatever time, and then went back down. So there was some kind of zero velocity over here. So v final will be equal to 0. So knowing this information, we can calculate using a formula. We can use this one, or we can't use this one actually. We can use this one again. So we write it as v final, which is 0 equal to acceleration, so negative 0.2 multiplied by the time that we don't have, and then with the initial velocity of 1.75 meters per second. And if we just do the formula in a calculator, we will get 8.75. So delta t, 8.75 seconds. And that is the answer. So here we have a race car that travels on a straight racetrack. So moving on a straight track with a forward velocity, so the initial is equal to 44 meters per second. And slows down and slows at a constant rate to a velocity of 22 meters per second over 11 seconds. So it slows down, meaning that acceleration here is negative. But the question doesn't really ask for the acceleration, it asks for the displacement, so we don't really need it. And it slows down at a constant rate to a velocity of 22 meters per second. So v final is equal to 22 meters per second. And the time it took for it to slow down is going to be equal to 11 seconds. So how far did it move? So when we talk about displacement, we can use two formulas. We can use this one, or we can use this one. And this one is time independent, but we have time, so we won't use it. So which one are we going to use? We're going to use whichever you want. Uh, yeah, we can use whichever one. Except, actually, we can't use this one because there's acceleration, and we don't have acceleration, so we're going to use this one. So we're just going to write it again here. Delta x is equal to v initial plus v final over 2 multiplied by the time. So if we wanted to substitute it, we would write delta x is equal to 44 plus 22, 2 multiplied by 11 seconds. And then we'll get the answer of 363 meters. So delta x is equal to 363 meters. And that is how far it travels. So here we have a car, and it moves west, so negatively, with a forward velocity or acceleration of with the forward acceleration of negative or 0.22 meters per second. But since it's moving westward, it's moving in the negative direction, which is why the acceleration will be negative, because negative times positive is negative. So like the direction is negative, and then the acceleration is positive, but it doesn't matter because the direction is negative. So it's moving negatively at an acceleration of negative 0.22 meters per second squared. Next up, it's asking what was the car's velocity? So VI, we don't know. At point X, if it travels a distance of delta of 350 meters in 18.4 seconds. So we have delta X, and we have delta T. So which formula will we use? Well, we want to find the initial velocity, but we don't have the final velocity. We don't have the final. And the only formula that does that for us is this one right here. So we're going to use it, and we're going to write it here. So delta x, so x is equal to half at squared plus vi times t. So we can substitute here, and we can find the answer. We can do delta x is 250 equal to half at, which is a is negative 0.22, and then t is 18.4 seconds squared, plus the initial velocity times 18.4. Now just plop this in a calculator, and you will get initial velocity being 21.04 meters per second. That is going to be your answer. So for the final question, you have a bicycle, and you start your bicycle at the top of a hill. So you're at the top of the hill, and it goes downwards at a constant acceleration of 2 meters per second squared. When you get to the bottom, you maintain you're moving at 18 meters per second. So from here to here, your V initial is 0, your V final is 18. 18. And then you pedals maintain the speed of 18 meters per second for, I mean, if you continue at the speed for 1 minute, so for one entire minute, there's 1 minute, or 60 seconds, and you're at a constant accelerate or velocity of 18 meters per second. So it's asking for the displacement from both of these, the entire displacement. So here we can call this A, call this point B, and we call this point C. Let's find AB first. So let's list out our given. We have the initial, which is 0. We have the final, which is 18 meters per second. And we have the acceleration, which is uh, 2 meters per second. Let's use the formula. That's time independent since we don't have the time. Or this one's time independent, yeah. And then we can solve for AB. So let's split this into AB and then BC over here. So let's find AB by using this formula. B final squared plus B initial squared is equal to 2A delta X. We can substitute what we have. We have V initial, which is 0, and then 0 plus 18 squared is equal to 2 times 2, and then we want to find delta X. So if we just use a calculator to find this, we get delta X is equal to 81 meters. Now for the next question, we want to find the distance traveled with time. So now that we have time, we can use the formula velocity is equal to delta x over delta t to find the displacement, since it's average velocity, right? We have an average velocity of 18 minutes per second, or 18 meters per second, and then we have the time, which is 60 seconds. So we can simply substitute it. We have 18 is equal to delta x over 60, and then we get 1080 meters. But we're not done yet. We need to add them. So delta x. So delta x total is equal to delta x 1 plus delta x2. So this will be equal to 1080, or in this case, it's 81 plus 1080, which is equal to 161 meters. So this is our total displacement. That will be it for lesson 3.2, motion with constant acceleration. If you have any questions or want to ask anything at all, you can ask it down below in the comments or in the server. If you want more videos like these, you can find them in the channel, and yeah, enjoy them.